In today's note, we're going to look at solving systems by substitution. So in the last lesson, we looked at solving systems graphically. So again, remember, a system is two or more linear equations, and we're trying to basically solve them or come up with a solution, and that means to find where do they cross. And graphically, that was the point of intersection. Now, it may be tedious to draw a graph, or the equations that we're given may not be in y equals mx plus b form, so it may be difficult to actually solve or rearrange it to graph. So instead of doing that, we do have another method in order to solve a linear system, and that's substitution. So the first step in substitution is to choose one of the equations. Remember, the system is going to be 2. So we're going to be given one equation, and we rearrange it for one of the variables. So we rearrange the equation to isolate one of the variables. And we want to try to avoid fractions. And I'll go through some examples so we can kind of hopefully see what I mean by that. Next, we're going to substitute the rearranged equation into the other equation. So the one that we rearrange, we're going to substitute that back into the other equation, the one that we didn't touch. Step 3, we want to solve for the remaining variable. So by substituting one equation into another, we make it so that there's only one variable remaining and that we can solve for that. Then we're going to sub that value into one of the original equations and solve. And then finally, we're going to check our answer and state the solution. So I'm going to start looking at the first one in this example here. So I'm going to label our equations 1 and 2. So the first step that we want to do is choose one equation and rearrange it for one of the variables. And in order to avoid fractions, you want to choose a variable that either doesn't have a constant in front of it, or the constant that is in front of it can be divided into all the other constants. Or sorry, not constants, coefficients. So if I look at my two equations, I can see one variable, the x, in my first equation that doesn't have a coefficient in front of it. So there's no number in front of it. So that's going to help me avoid fractions, because when I rearrange, I don't need to divide by anything. So my first step is going to be to rearrange equation 1. So if I have x minus 2y equals 4, to get x by itself, I'm going to move the minus 2y over. So I get x equals 4 plus 2y. So that is now my first equation rearranged, and I've avoided fractions because there's no fractions in this equation. Step 2 is to substitute this equation into the other one. So now we're going to sub it into equation 2. And what I mean by that is that if I have my original equation, 2x minus 3y equals 7. Everywhere I see an x, I'm going to plug in what x equals from equation 1. Right? So this 4 plus 2y is going to be subbed in for x. So I'm going to get 2 times 4 plus 2y minus 3y equals 7. So now I've substituted it in. The next step is to solve for my variables. And I can see that by substituting it in, I only have one variable remaining, which is y. So now I can solve this. So I'm going to multiply, or let me rewrite it. So 4 plus 2y minus 3y equals 7. I'm going to distribute this 2 through, so I get 8 plus 4y minus 3y equals 7. I can continue to solve. 8 plus 1y equals 7. I want to get 8 by the y by itself, so I'm going to move the 8 over. So I get 1y equals 7 minus 8. Or basically y equals -1. So now I have the value of y. So I know that the y value of my point of intersection is going to be -1. The next thing I want to do now is substitute that back into one of the original equations and solve. So I'm just going to say sub y equals -1 into, let's just say, equation 1. Again, you can choose either equation. It shouldn't matter because, again, remember, the point of intersection should be the same. So I'm going to sub this back in. So if I start with my equation 1, which was x minus 2y equals 4. So I get x minus 2 times -1 equals 4. X, and then I have plus 2 equals 4. I want to get the x by itself, so I get x equals 4 minus 2, or x equals 2. So that means right now, therefore, my point of intersection is going to be the point 2, -1, or that's my solution to the linear system. Right? The last step we can do is check. So in order to check, I need to do left side equals right side for both equations. So the first one, I have x minus 2y, and I have 4. So I have 2 minus 2 times -1. So I'm just taking that POI that I found, or the values that I found, and plugging it in. And I have 2 plus 2 is 4. So this first one is good. So equation 1 is good. Equation 2, again, I'm going to do left side equals right side. Equation 2 I haven't used much of, so 2x minus 3y. 2x minus 3y equals 7. So then 2 times 2 minus 3 times -1. So we get 4 plus 3, 7. So this works. So therefore, 2, -1 is the correct solution. So that's how you can check your answer to make sure that the point of intersection that you found is the correct solution to this linear system, which it was. So moving on to the next example, I'm going to go through the same thing. I'm going to rearrange one of the equations, and by looking at these two, this time the y seems to be the better option because it's by itself already. So if I label them 1 and 2, I'm going to rearrange number 2. So I have 2x plus y equals 6. I'm going to rearrange it. I'm going to move the 2x over. So y equals 6 minus 2x. Next, make sure I get my colors right. So next, I'm going to sub into equation 1. So I have 3x plus 2y equals 4. 3x plus 2, and now instead of y, I'm going to put my rearranged equation. So I'm going to replace the y with 6 minus 2x equals 4. I'm going to solve now. So I'm not going to rewrite it just because I'm adding more space, but I'm going to start to go through and solve. So I'm going to distribute this property. So I get 3x plus 12 minus 4x equals 4. Collecting some like terms here. So I get negative 1x plus 12 equals 4. Move the 12 over. Negative 1x equals negative 8, because 4 minus 12. And then I'm going to divide by negative 1 on both sides. So I get x is equal to 8. So I've found part of my solution. I know the x value is 8. The next one that I'm going to do, I'm going to sub x equals 8 into, and again, it doesn't matter. I'm going to go back and sub it back into that same one. So I'm going to plug it into equation 2. Again, you can choose to do it to either one. You should get the same answer regardless, if this x value is correct. So equation 2 was 2x plus y equals 6. So 2 times 8 plus y equals 6. And then we have 16 plus y equals 6. Move the 16 over and we get y equals negative 10. So that means then, based on what I've done so far by substitution, therefore the POI, or the solution, is 8, negative 10. Now to confirm that, I need to check my answer by plugging this point of intersection back into my two equations. So I'm going to do it for equation 1, left side and right side. So equation 1 was 3x plus 2y equals 4. So 3x equals 3 times 8 plus 2 times negative 10. 4 stays the same, so I get 24 minus 20, which equals 4. So left side equals right side for equation 1, so that's good. Equation 2, left side, right side. So equation 2, right side was 6, and then 2x plus y. So 2 times 8 plus negative 10. So 16 plus negative 10. So 6 equals 6, which is good. So therefore 8, negative 10 is the correct solution. So again, you don't need to go through and check that or check your answer every single time, but again, it is helpful to double check to see if you got the right answer. So looking at example number 2, Maria and Nancy played in a volleyball marathon for charity. They played for 38 hours and received $412. Maria was sponsored for $10 an hour and Nancy was sponsored for $12 an hour. How many hours did each play? So what we're going to do here is we need to come up with our equations. So I need to figure out what my variables are going to be. So let's say let x equals number of hours Maria played, and y equals number of hours Nancy played. You can choose whatever variables you want as long as you identify what they represent. So now we need to come up with two equations. Right? In order for it to be a system, we need to have at least two. And in all the examples we're going to look at, it will be 2 only. So the first one is going to be, we know that they played combined 38 hours. So the first one is going to be x plus y equals 38. So Maria's hours plus Nancy's hours equals 38. Next, we're going to have one that's associated with the total money. So 10 hours, or $10 an hour, times the number of hours that Maria played, so x, plus 12 times the number of hours Nancy played, or y, is going to equal 412. Now that we have our two equations, we can choose one of them and rearrange for a variable. In this case, I'm going to choose equation 1, and I'm going to choose it again because it's x and y, there's no numbers in front of them. Either one is fine. I'm going to choose x just because. You could choose y if you want. The only difference would be that you're going to get your y value first and then have to solve for the x later. So now that I have that one, I'm going to sub in this equation, or I'm going to rearrange it. So let's start over here. Rearrange equation 1. So x plus y equals 38. I'm going to get the x by itself, so x equals 38 minus y. Next, what I have to do, substitute into, or sub into equation 2. So I have 10x plus 12y equals 412. So it's going to be 10, and instead of x, I'm going to put 38 minus y plus 12y equals 412. And now I have to solve. Actually, let's go back and keep this color coded. So that was black, blue, and now we're going into solving. So in order to solve, I'm going to distribute this property. So 380 minus 10, or no, sorry, or yeah, minus 10y plus 12y equals 412. Now I can solve for my y value because that's the only one that's remaining. So I do have some like terms. So 380 plus 2y equals 412. I want to get rid of the 380. So 2y equals 412. Because I move it to the other side, I subtract it. It's 32. You can divide by 2 on both sides. And I get y equals 16. So that means I have a y value of 16, and my final step is to sub y equals 16 into either equation. I'm going to sub it into equation 1 because that's going to be the easiest to solve. So I have x plus y equals 38. So x plus 16 equals 38. Move the 16 over. I have x equals 38 minus 16. And then when I solve that, I have x equals 22. So that is my final solution. So therefore, Maria, which is represented by x, played 22 hours, and Nancy played 16. So that is using substitution to solve this word problem. Example 3, Maria is starting, let me back, so now everything's kind of color-coded based on those steps. So example 3, Maria is starting a business in which she will hem pants. Her startup cost to buy a sewing machine is $1,045. She will use about 50 cents in materials for each pair of pants. She plans to charge $10 for each pair of pants that she hems. How many pairs of pants does she need to hem to break even? So again, the first thing we want to do is come up with an equation to represent this scenario. So we're going to have to come up with one for her cost. So C equals, and we're going to come with one for the revenue. So R equals So the cost is going to equal 50 cents per pair of pants, so that X equals number of pants, plus the $1,045. The revenue, or the amount of money she's going to make, is going to be 10 times X. In this case, in order to break even, so to break even, a company's costs must equal the revenue. So C must equal R. So this one's going to be a little bit different, but we're still plugging two equations into each other. Right? So if I go through, I have the cost, so 0.50x plus 1045 is equal to 10x. And now I'm going to solve. Right? I want to get my x's on one side, so I'm going to move, or my variables on one side, so I'm going to move this over. So I get 1045 equals 10x minus 0.5x. 1045 equals 9.5x. To solve, I'm going to divide one side by 9.5, the other side by 9.5. It'll cancel it on one side, and I'm left with 110 equals x. So in this case, therefore, she must hem 110 pairs of pants to break even. And if you wanted to, you could take this value and plug it back in to see at what dollar amount does she break even, or how much money does she need to make to break even based on that pair of, or that number of pants. But again, in this example, or in this note, the key thing is learning how to solve by substitution. So we have a couple of examples here. We have the steps to go through, and if you're ever unsure of your final solution, just check your answer by plugging it back into both equations and checking if left side equals right side.